Each of these examples for problem number 3 are going to be slightly different than what you may see on the test itself. What you're looking to do is graph and then inspect that graph so that you can find the domain and the range. You should hopefully be masters of graphing most of these polynomials. As I look at this one, I recognize this being nothing more than a parabola. And so I'm going to start by sketching a graph of my parabola. This is going to be a shift over 2 units. So I go right to the 2 units and then down 7. 1, 2, 3, 4, 5, 6, 7. And so I'm down here with this first point, that's my vertex. With a vertex at 2, 7, I want to graph with this stretch, which tells me to go right 1, left 1, and I can go up 3 units. So I'm going to go right 1, up 1, 2, 3, put a point. In a similar way, I can go left 1 and up 1, 2, 3, put a point. As I go right 2 units, the standard stretch is to go up 4, but because there's a 3 there, it's telling me to go up 12, because I do 3 times 4 is 12. So that would be 7, 8, 9, 10, 11, 12. The next points would be here and there. Now, I'm not going to connect the dots because I also have to look at this absolute value. This absolute value is going to take anything that was beneath the x-axis and reflect it up. And so as I'm looking at this, this will come down as such. But everything that was supposed to be down here beneath the x-axis gets reflected up. Now when I talk about the domain and the range, the domain is the collection of all x values that can be plugged into this function. I can plug any negative value, because this function just goes up forever. I can plug any positive value in there. In other words, it's continuous. It works all the way through. And so in interval notation, to plug any x value that exists in here, I would say that I can go from negative infinity to positive infinity. Again, we use parentheses there because you cannot contain infinity, but this essentially means all real numbers can be plugged in for your x values. As I look at the range is only where the y values exist. The lowest I could go is 0. I can't go any lower than this, so my range would be 0. No, I can contain that right here and here. Those are actually zeros. So I use my bracket, I go 0, and then it goes up forever. And since it goes up forever, that would go to positive infinity. And so the solution for this, as I'm looking for the domain and range, is that I can have any value I want. So I go negative infinity to positive infinity for the domain. And the range would be the collection of all values greater than or equal to 0. And we list that as bracket 0, comma, infinity. That's example 3A.